and welcome. Today we'll walk you through how to use the NIRxWINGS2, our extension for the NIRxPort2, to measure peripheral physiological signals, to use as covariates and boost your SPA-fNIRS analysis. The NIRxWINGS2 kit comes in a convenient carry-on case. In the box you will find the main unit with the Bluetooth dongle, a sensor for electrodermal activity, including finger electrodes and electrolyte gel, a sensor for EXG bipolar signals, for instance for EMG or ECG, with one ground cable and disposable electrodes, a sensor for temperature, including finger straps for fixation, a sensor for respiration with respiration belts in 2 sizes, a sensor for SpO₂ or peripheral oxygen saturation, PPG or photoplethysmography and heart rate, a USB Type-C cable, a hip belt with a hook and loop fastener for the main unit, and various kinds of tapes. The main unit is the core of the Wings2. At the top of the module there is a holding niche where the Bluetooth dongle can be stored. On the back, it showcases 8 proprietary NIRx BioLink ports, which can be flexibly used for any of the sensors, except for one 9-pin port on the front side, dedicated to the combined PPG HR SpO₂ sensor. On the front side of the device, there is the on-off switch, the USB charging port, and the status LEDs. When the device is on, the first LED turns green, and while the device is charging, the right LED turns red. The NIRxWINGS2 set includes 5 sensors to simultaneously collect peripheral biosignals. The EXG sensor consists of an active bipolar sensor with 2 sensor leads. Red is positive and blue is negative, and a reference lead in black that has to be inserted in the socket to increase signal quality. If using multiple EXG sensors, one reference electrode must be used. This single sensor can be used to measure electrocardiography, electromyography, and electrooculography. First, make sure that the surface to which you are affixing the electrode is clean by softly rubbing the area with alcohol pads. The disposable pre-gelled electrodes can be stuck to the skin after peeling the protective layer off the bottom of the electrode. The position of the electrode is dependent on the desired application and signal of interest. For example, for ECG you can place the blue lead on the right clavicle below the collarbone, the red lead on the lower left rib, and the reference electrode on the lower right rib. Different ECG configurations are possible. For EMG, electrodes are placed around 2 cm apart over the muscle of interest. For example, to get forearm contractions, place both active electrodes side by side over the brachioradialis muscle and the reference electrode on the inner part of the wrist. The sensor amplifier box can be fixed to the body, for example using tape, to avoid excessive movement artifacts. The electrodermal activity sensor measures how well the skin conducts electricity. Conductivity increases with higher sweat gland activity. When recording from the fingers, connect the Velcro straps to the electrodes, apply a drop of isotonic gel onto the metal clips, and then place the 2 electrodes on the middle phalanx of either the index and middle or the index and ring fingers. Firmly secure the Velcro straps around the fingers. When recording from the palm, connect a disposable non-polarizing electrode to the metal clip and place one of them on the thenar and the other on the hypothenar side of the hand. The temperature sensor measures temperature on the surface of the skin. Place the sensor on the subject's area of interest and secure it using the provided tape. In particular, the blue tip of the sensor must be in contact with the skin. You can use some additional medical tape to fasten everything, but be careful to not bring any adhesive glue in contact with the sensor, as it might degrade sensor performance over time. If the area of interest is the finger, you can place the sensor tip inside the finger strap and firmly wrap it around the finger. To measure respiration, a belt is available in 2 sizes, 95 and 120 centimeters. It is fixed by 2 Velcro pads and contains 2 clip connectors to connect the sensors. A wire connects these sensors and it detects any stretching of the belt due to breathing. Place the belt on the part of the body that moves during breathing, for instance on the chest or abdomen, with the metallic clip connectors facing outward. Ensure that the belt is tight enough to stay securely in place during the measurement, but not so tight that it becomes overly stretched or uncomfortable. It is better if the subject is wearing a thin layer of clothing or none at all. Connect both electrodes from the sensor to the metallic clip connectors on the belt. Ensure the Velcro strip side of the amplifier faces inward to attach it to the belt. This will help reduce cable tangling, movement artifacts, and abrupt changes in the signal. Make sure the zeroing button remains accessible. This button can be pressed for around 10 seconds to reset the baseline of the measurement. To acquire blood volume changes, instantaneous heart rate changes, and blood oxygen saturation, the clip contains on one side an LED emitting infrared light and a photodetector on the other. Blood absorbs light differently depending on its volume and level oxygenation, determining ppg, HR, and SpO₂. Clip the sensor onto the subject's earlobe or fingertip. If your experiment involves movement, you can secure it with the provided tape. After installing all required sensors on your participant, simply plug them into the main unit of the NIRx2. The ppg sensor gets plugged into the 9-pin port on the front side of the main module. All other sensors get plugged into the ports numbered 1 to 8. It doesn't matter which port the sensors are plugged into, since the NIRx2 will automatically recognize the presence and the type of the used sensors. In order to connect the NIRx2 to the NIRx2, take out the Bluetooth dongle from its holding niche on the main module and connect it to the USB port on the NIRx2 using the provided USB-C cable. If multiple NIRx2 devices are daisy-chained, the dongle should be connected to the primary device. Now you are ready to turn on the NIRx2 as well as the NIRx2. When in standby mode, the light on the NIRx2 dongle is blue. As soon as the device is detected in Aurora and while recording, the dongle light starts flashing. Open Aurora on your acquisition PC. Opening the device selection page as usual, the NIRx2 will show up with a W symbol that indicates the presence of the NIRx2. After selecting or creating a configuration that includes biosignals, you can proceed with your fNIRS signal optimization and start your recording. When starting the recording, the experiment information window appears. In the right tab, called Wings Channels, you can check which channels and therefore which sensors are active. After we start a recording as usual, you will see that there is a new page for biosignals, in addition to the fNIRS data visualization tabs. As you can see, each of the sensors we have previously mentioned and set up are now being shown in real time. For each plot, standard filtering options are pre-selected, and there are options to change the filter range, as well as the scaling of the data display. This view allows us to look at the signals and potentially troubleshoot any potential issues. For example, let us take a closer look at one of the signals. There are different visualization options. You can automatically or manually scale the display of your data. You can visualize the raw or the filtered data. Finally, you can change the time window display. It is important to note that none of the visualization options in Aurora, including filtering, affect the recorded data, which is always recorded and saved at the full sensor bandwidth. The physiological signals recorded from the NIRx2 are sent to Aurora via the NIRx2. This means that any trigger information from your experiment will automatically be present in the physiological data as well. For the remaining sensors, our manual has all the necessary information to understand and troubleshoot the signals. Please review the documentation carefully before your recordings. After finishing the recording, the data is stored in the local data folder of the recording PC. The SNIRF file, which is the fNIRS community's preferred file format, includes the data from the fNIRS as well as the physiological recordings. The NIRxWINGS2 raw data is also saved as a WINGS file in the zipped folder inside the recording folder. In a data analysis program such as Satori, the physiological data can be inspected and used for pre-processing or statistical analysis. On a final note, if you are using multiple sensors on your participants, we recommend paying close attention to the cable management, as each sensor has its own cables, and cables should not be tugging or extremely taut during measurements. For example, attaching the sensors to the body in a proximal to distal way might help when the respiration belt is included. For any additional information, please refer to the WINGS2 user manual in the NIRx Learning Center or contact our support team.